to English 1 at the University of Crete. I'm Noni Rizopoulou, and in this video we'll see how programming languages can be the tools we use to communicate with computers. They let us write instructions, solve problems, and create software. Over time, languages have evolved to be more powerful, flexible, and human-friendly. A programming language is a formal way for humans to instruct computers what to do. It provides rules for how commands are written, the syntax, and what they mean, the semantics. Using a programming language, we can express logic, design algorithms, and build programs that perform tasks, process data, or control systems. Programming languages act as the bridge between human ideas and machine execution. Programming languages have evolved from low-level instructions tied closely to hardware to high-level languages that emphasize abstraction and readability. Early languages like machine code and assembly required detailed hardware knowledge. Later, structured and procedural languages improved clarity and reusability. Object-oriented and functional styles introduced new ways of modeling problems. Today's languages combine multiple paradigms to support safer, more concurrent, and more portable software development. A programming paradigm is a style or philosophy for structuring and reasoning about programs. Different paradigms emphasize different ways of thinking. For example, sequences of steps, declarations of facts, mathematical transformations, or objects interacting. Many modern languages support more than one paradigm, allowing developers to choose the toolset that best fits a given problem. Procedural programming organizes code into ordered sequence of steps grouped into procedures or functions. Programs follow a clear flow of control using constructs such as loops and conditional statements. This paradigm is effective for problems that can be decomposed into well-defined tasks. Classic examples include C and Pascal, but many languages incorporate procedural elements. In declarative programming, developers specify the desired outcome without listing the step-by-step process to reach it. The system determines how to produce the result. This paradigm is widely used in database queries, constraint solvers, and logic-based systems. SQL and Prolog are well-known declarative languages. Declarative approaches help reduce complexity by shifting the focus to intent rather than procedure. Functional programming is a paradigm where computation is treated as the evaluation of mathematical functions. Unlike imperative programming, it avoids changing the program's state or mutable data, which makes reasoning about code simpler and more predictable. Functions are first-class citizens, meaning they can be assigned to variables, passed as arguments, and returned from other functions. Immutability is emphasized, so once data is created, it cannot be modified, reducing side effects and making programs easier to debug, test, and parallelize. Overall, functional programming promotes clearer, more reliable, and maintainable code. Object-oriented programming structures software around objects that represent real-world or conceptual entities. These objects encapsulate data, attributes, and behaviors, methods. OOP supports modularity and reuse through mechanisms such as inheritance and polymorphism. This paradigm is widely used for building complex systems where modeling real-world relationships is important. Variables act as named containers that store information while a program runs. They allow data to be referenced, updated, and passed between functions and operations. Depending on the language, variables may have fixed types defined in advance or dynamic types determined at runtime. Variables are fundamental for maintaining state, performing calculations, and guiding program behavior.